Hi everyone, I'm Linda. In this presentation video, I'm going to talk about the hydrogel adhesives in medical applications. Let's get started with the definition of the hydrogels. Researchers over the years have defined hydrogel in many different ways. Hydrogel is a three-dimensional network of hydrophilic polymers that can swell in water and have a large amount of water while maintaining the structure due to chemical or physical cross-linking of individual polymer chains. Hydrogels, as hydrophilic gels with 3D network structures, generally have a good biodegradability, biocompatibility, adhesion, air permeability, and maintain the moist environment for cell migration, which can effectively promote the cell proliferation and facilitate wound healing. The importance of and properties of hydrogel. It should have a good biocompatibility, biodegradability, moisture retention, antibacterial, antioxidant, high water content. The high amount of water content in hydrogel allows for excellent biocompatibility, physical similarity with tissue, and encapsulation of hydrophilic drugs. Softness and flexibility. Hydrogel adhesives are generally soft and flexible material, which allow them to conform to the irregularity of the surface. This flexibility enhances the adhesive properties and improve the contact between the adhesives and the substrate. It should also have a good mechanical properties. The mechanical properties of hydrogel are considered as one of the important parameters for engineering design of hydrogel for medical applications. In order to prevent the spoil and detachment of the hydrogel adhesive from tissue during the movement and stretching of the tissue, this mechanical property of excellent hydrogel adhesive should also match the target tissue. Stimuli responsive adhesions. Some hydrogel adhesives can exhibit stimuli responsive adhesion where the adhesive strain can be modulated in response to environmental stimuli. The adhesive should be easily applied and injected in the form of liquid or hydrogel on the target surface. Removable or removability. Hydrogel adhesive can often be easily removable from the adhesive surface without causing damage. This property is important in medical applications where gentle removal is desired to minimize trauma to the tissue. This slide talks about the main component of hydrogel. Hydrogel are all made of similar ingredients, monomer initiators that link monomers into chains, cross-linker, which connect the polymer chains to one another, and water act as the solvent which disperses the ingredients. To control the heat of polymerization and the final hydrogel property, diluent can be used, such as water or other aqueous solution. Then the hydrogel must need to be washed to remove impurity left from the preparation process. These include non-reactant monomer, initiator, cross-linker, and unwanted product produced via the side reactions. In general, hydrogel can be prepared from either synthetic polymer or natural polymers. As you can see in this figure, hydrogel forming natural polymers include proteins such as collagen and gelatin and polysaccharides such as starch, alginated agarose, chitosan, cellulose, etc. For the synthetic polymers that form hydrogel, are traditionally prepared using chemical polymerization methods. Any of the various polymerization techniques can be used to form gel, including bulk, solution, and suspension polymerization. The preparation of hydrogel adhesive typically involves synthetic or formulation of the hydrogel material with adhesive property. The exact method may vary depending on the specific type of hydrogel adhesive and its intended application. As you can see in this figure, it shows about the common design principle of hydrogel wound adhesive. It is important that the specific detail and method for preparing hydrogel adhesive can vary depending on the desired property, application, and material use. Any technique which can be used to create a cross-link polymer can be used to produce hydrogel. Co-polymerization, cross-linking, free radical polymerization are commonly used to produce hydrogel by reacting hydrophilic monomer with multifunctional cross-linker. Water-soluble linear polymer of both natural and synthetic origin are cross-linked to form hydrogel in a number of ways. First, linking polymer chain with chemical reaction. Second, using ionized radiation to generate main chain free radicals, which can recombine as cross-link junctions. And third, physical interactions such as entanglement, electrostatics, and crystalline formation. The preparation of hydrogel adhesive typically involves in the synthesis or formulation of hydrogel material with desired property as mentioned previously. Here are a general overview of the steps involved in preparing hydrogel adhesive. Choose suitable hydrogel material that possess the desired property for the adhesive application. Common hydrogel material used for adhesives include polyethylene glycol or polyvinyl alcohol, and the various natural polymer like arginate or gelatin. Another step, cross-linking method. Determine the appropriate cross-linking method for hydrogel is related in this. Preparing hydrogel, cross-linking helps stabilize the hydrogel structure and provide adhesive property. Cross-linker can achieve through physical cross-linking or chemical cross-linking. If the hydrogel adhesive is based on a polymerizable monomer or pre-polymer, initiated the polymerization reaction or gelation process is conducted. This may involve mixing the monomers or pre-polymers with the suitable initiator, catalyst, or cross-linking agent to allow interaction process until the hydrogel forms. Another step, incorporating of adhesive component to impart adhesive property. Incorporated adhesive component into the hydrogel formulation. This component may include tackifier, adhesion promoter, or surface modifying agents. After that, optimizing and testing. Optimize the formulation and composition of hydrogel adhesive through experimentation. Then test the adhesive properties such as adhesion, strength, stability, biocompatibility, and so on. This we talk about the advantages of hydrogel adhesive. Adhesive and sealant can be successfully employed in the treatment of emergency hemostasis, in sealing leaks of gas or fluid, and its reinforcement of sutures. Effectively manage moisture at the application site, promoting a moist environment that can enhance wound healing and prevent tissue dehydration. Hydrogel adhesive can have the ability to adhere to a wide range of surfaces, including wet or irregular surfaces such as skin, mucous membranes, and organs. Hydrogel can adapt to the shape and movement of body, providing the comfortable fit and minimizing discomfort for patients. Another advantage is hydrogel can be formulated to incorporate drug or therapeutic agents. Hydrogel adhesives are typically non-toxic and non-irritating to the body, reducing the risk of adverse reaction. Hydrogel adhesive can be designed to have a gentle adhesive strength, allowing for easy and painless removal with matching the underlying tissue, beneficial for application of wound dressing.
Hydrogel adhesive can be used for closing the resulting tissue continuity or attaching devices to tissue in surgical applications like wound closure. Here is some references that support the information that contained in this video. And finally, I hope you enjoyed this video and thank you for watching.